one more example. This one is another one that is almost a memorization problem. It's a antiderivative that requires sort of a extra knowledge, a creative leap. The other one was the antiderivative of natural log. This one is the antiderivative of the inverse tangent to the -1. That's what that is there. Tangent to the -1 of x. So the same exact function as arctan. You can write it as tangent to the -1 or arctan. I decided to do this one with a limits of integration too, so we can practice pulling in some numbers at the end. But the creative leap here, and now it's just a memorization I suppose, is that you can use integration by parts to find it. And similarly to the natural log, this one you let u equal the whole thing, tangent inverse of x, and then dv is just the dx. So taking the antiderivative of dv there just gives you back x, because that's the antiderivative of 1 times dx. The derivative of the inverse tangent is also a function that we have memorized. That's the one that becomes 1 over 1 plus x squared. So now watch what happens when you use the integration by parts formula. You get that the integral is equal to uv x times the inverse tangent to x, 0 to 1, since we do have those limits of integration to plug in, minus the integral of v du from 0 to 1, and that one is x times 1 over 1 plus x squared. So x over 1 plus x squared dx, which now allows a u substitution. Let u be that whole denominator, 1 plus x squared. That's the handiest thing. And when you take the derivative of it, you get 2x dx, or 1/2 du equals x dx. And then the x times dx is the numerator times dx. And so that just gets replaced with the 1/2 du. And the denominator was u, so we make that 1 over u, and that's the natural log of the absolute value of u. Had to keep that minus sign that was outside there, and also going to plug in 0 to 1. So there's the whole thing. I do need to remember that 0 and 1 were my x values. So what I like to do is replace the u with 1 plus x squared in this case, so that I can see the whole antiderivative in here. If I wanted to, I could check that I had the right antiderivative by taking the derivative of all that with respect to x. And now I can plug in x equal to 0 and x equal to 1. And let's do that carefully. Tangent inverse of 1 is pi over 4. Times 1, and tangent inverse of 0 is 0. Then I get a natural log of 2, plugging in 1 for x squared, and natural log of 1, plugging in 0 for x squared. Natural log of 1 is 0, so I'm left with just pi over 4 minus 1/2 of the natural log of 2, or natural log of 2 over 2.